Hello, everyone. I'm Henry, and I'll be your host for the May 2026 Variety Hour. For those of you who are joining us for the first time, Variety Hour is our monthly community event, which connects members of our community with exciting projects, research, and ideas that are happening in the field of conservation technology right now. We've got some great talks lined up for you today, which focus on how AI is reshaping the way that we understand, monitor, and protect the natural world. And of course, we have our famous ad break and quiz to look forward to as well. So, in terms of the agenda, first up we have Moshe, who will be talking about Deep Voice, which translates ocean soundscapes into conservation action. Then we have Barney, who will talk about using AI and drones to transform wildlife monitoring. And then our last short talk, delivered in the first half of the call, will be from William on AI-assisted video review to enhance bat surveys. We're then going to have our intermission and the famous Wild Labs quiz. And then finally, our long talk today will be delivered by Martin on Global Nature Watch, which is a tool which provides AI-powered insights for nature. So I think without further ado, I'm going to stop sharing my screen and we can get started. I'm going to hand over to Moshe for our first short talk. Thank you.
Yeah, thank you, Henry. So nice to meet you all. I'm Moshe from Deep Voice, based in Tel Aviv. So I'll do a quick demo, basically, of a tool we recently built with the help of the WILDLABS Awards funding, and I'm really excited about this. So in a nutshell, in Deep Voice, we develop AI-assisted tools to aid biologists and conservation people to help endangered species, marine mammal, fish, anything that emits sound. So we provide passive acoustic monitoring tools. And up until recently, most of our work was done on our servers. So biologists working with us had to send over all their data to us, which is quite cumbersome and pretty, it has a lot of friction. So what we built is a really cute and small platform where you can upload your data and choose the model you wish to use from this dropdown. Currently, we have here different 8 supported models. We plan to expand this list, and also we get requests. So if you have any interesting project you're working on, please don't hesitate to call. So yeah, let's do a quick demo. Let's say I want to try the Arctic codfish. Here we get some information about the model, for example, the sample rate it needs, the collaboration. So thank you, Shay, for this amazing data. So let me just take a WAV file, drop it here. So you can see it was uploaded, and that's pretty much it. I'll just click on Run Inference, and everything is working on, on the cloud, on Hugging Face spaces, and it's absolutely free. So here we can see that a 5-minute audio was analyzed in about 2 seconds. So I'll just download the Raven compatible results. Here we also got the raw results if you prefer to get the full breakdown of every window, basically, that the model has inspected. So now I'll just take the downloaded file, load it to Raven. I just open it here, open selection table. And here we got pretty much a new table with the vocalizations. And you can see here that we got this little grunt that is actually what we're looking for. So instead of going over the entire 5 minutes of recording, we can just go over the model's prediction, listen to them. So this small bloop or grunt is actually what we're looking for and what Shay is looking for. So we can inspect other calls as well, and you can see that we also got the model's probability of the call. So here we can see that this is probably a false positive in this one, and we can also see that the probability is quite low. I mean, this is also, as we saw earlier, a tool we can use when we emit this prediction of the model. Here we can see another grant, and that's it. Instead of going over the entire 5 minutes, we can just, use those model prediction and save a lot of time when working with acoustic data. So yeah, thank you very much for the grant and the opportunity to create this tool. I think it's really useful. If you have any issues with it, please don't hesitate to contact us on our info@deepvoicefoundation.com or just contact me. I can leave my email in the chat later. And please let me know if you have any more requests or collaboration you would love to have and models you would love to deploy here.
Thank you very much, Moshe. Very cool. You've actually got a couple of minutes left, so I was going to ask if anyone's got any questions, Moshe, or anything they want clarification on. But otherwise, if you have a couple of minutes, is there anything else you wanted to show from the tool or anything to demo?
Actually, I can just talk about the foundation in general because the tool is, as I said, pretty self-explanatory. And please use it and try to break it because this is what usually creates the best tools. So right now we also have a collaboration with Raven. We're one of the beta testers to help them deploy PyTorch-based models in their new to be released Raven Intelligence, which is really cool. It means that people will be able to use our models on their edge devices, on their computers, basically, instead of sending the data over to Deep Voice, which is really exciting. And a really big project that we're working on right now is creating a classifier for the North Atlantic right whale. This is a big grant we got from the vessel strike avoidance from the NFWF, and I'm super excited about it. It's a super complicated yet challenging task, and I'll update about it more in the forum once we have more results to show you about.
Thank you very much, Moshe. Appreciate it. Thank you. We've had one question in the chat from Martin Brook. Does it detect birds it has not been trained on?
So actually, this is part of the things I would love people to try. Basically speaking, usually the models are quite adapted to the species they were trained on. So when we have this big domain shift, usually it won't work out of the box, but sometimes models surprise us and we actually see that models can pick up some vocalizations from other species as well. So the best thing I would do is, like, for starter, because it's so easy, I would just upload and see if it catches it or not. We do think about integrating other amazing open source models which are not yet supported. I mean, for example, the Perch model by DeepMind and Google. This is a really exciting model, but I haven't found any serving platform that actually enables biologists to play with it. You have to be computer science researcher to get access to it. So we think to add another section of open source models as well so people could interact with.
Thank you very much, Martin. I hope that answers your question. And that's us for time. Thank you so much. Barney, I'm going to hand over to you now for our second talk. Thanks, Moshe.
Brilliant. Thank you. Hello, everyone. I'm Barney Stannah. I'm the co-founder and CEO of ACM, Aerial Conservation Monitoring. So when I finished my master's in wildlife crime, I was fortunate enough to spend several months in the field with rangers at Barana Conservancy in Kenya. What I saw was basically that the monitoring data that they're collecting and that they still rely on via traditional aerial survey counts is extremely inaccurate, expensive, and infrequent. And to be honest, you can't protect what you can't see. So we built ACM to fix this. So the problem is that rangers are relied on to cover tens to hundreds of thousands of acres every day, which leaves obviously it is physically impossible and leaves massive gaps in the landscape. And then the traditional aerial surveys that are designed to do the species counts, which are literally helicopters and planes still, and someone sticking their head out the side and basically trying to count all the animals that they can see whilst going at 300 kilometers per hour. It costs between 20 to 100K, and recent studies show they miss 40 to 45% of all the animals. So therefore, there's no full kind of clear picture of the landscape, and what that does is it leads to a massive increase in poaching, raiding, human wildlife conflict threats, and therefore danger to both the wildlife, but also, the rangers on the ground. So at ACM, what we're doing is we're building an aerial intelligence system, basically. What we're doing is building an AI model that can identify, count, and map species from aerial imagery. So our AI models will run on fixed wing drones and in the future also multi-rotor drones. All the footage during the flights will pass through our AI model, and the detections will be sent down to operations rooms in real time. So these detections will be georeferenced and geolocated and can be pushed into GIS mapping platforms such as Earth Ranger, and therefore giving rangers and conservancy teams a kind of full landscape visibility. And I had a call with the head of Earth Ranger the other day, which was extremely exciting as we are looking to integrate with their platform, and we have conversations kind of ongoing there. So there are kind of three main pillars that we're solving. I touched on the accuracy side. So Richard Lamprey is the author of that study, which shows that traditional aerial census operations miss 40 to 45% of all animals. I was actually on a call with him last week, and he said that this number is actually closer to the 70 percentiles, which is crazy considering the cost. And he's actually now taking a different kind of angle, which is photographing full protected areas. And this produces a huge amount of data, but he does it because it's more accurate. But the problem is his small team take around 9 months to analyze all of these photos and give an accurate count, which is just unfortunately not scalable. And then there's the emission problem. So take Barana Conservancy, where I was in the field. It's a very small conservancy, 132 kilometers squared. Helicopters and small aircrafts produce a huge amount of CO2. Compared to a fixed wing drone that's doing the same census operation on transects would be 90 to 97% lower direct emissions. And then the overarching thing is the cost. It's mandatory for most protected areas across East Africa and Southern Africa to do species counts, and they're done every 1 to 3 years. They cost an extremely, a massive amount of money. Helicopters, $25 per kilometer squared plus, and aircrafts usually between 12 to 18. But ACM, our drone censuses would be far cheaper, but the real value is in the output, georeference data, and in days rather than months. So where we are now is we completed a proof of concept at Barana Conservancy last November, where we collected 137,000 species tags, and that has led to the development of our V1 identification model, which is based on rhinos, elephants, and vehicles, and showed an average precision of 86%. We have multiple conservancies that have signed letters of intent and also have the technical and operational partners in place to scale, which is, very exciting. So we have an incredible team and advisory board, which I'm extremely privileged to announce. I've got my co-founder, who has been in many startups before, but we have Ian Redmond, who's a world-renowned conservationist, Michael Dyer, the managing director at Barana, Ted Schmidt at the Paul Allen Institute, Dan Morris, who I know many of you know, and I think he's on the call today, which is great to see, is our AI advisor, which is brilliant. And then Bakachi Akatsa and Aaron Kamikils are in-country drone operators and growth advisor, which is great. And then to touch briefly, what we're doing now is we're trying to raise 250,000, and this is to do 1 to 6 months of further validation and training, because it's extremely important to gather a variety of data over different environments, different seasons, and the specific animals in different environments to make sure that our AI model can transfer across different conservancies and landscapes. So that's a big part of what we need to do, and then hopefully go into some pilots and testing alongside traditional census operations. So this is kind of some pictures of me in the field at Barana. the AI identifying on the bottom right and the training in the bottom left. I just thought it'd be nice for you guys to have a kind of visual of that. And then obviously, you know, look at the Rangers on the foot patrols, these huge landscapes that they have to cover every day. But yeah, I just want to say thank you to everyone for listening, and those that will listen. I'd love for people to connect with me. I absolutely love talking about what we're building, and you know, I open to any conversation, whether people just want to learn more about what we're building, or yeah, further than that, you know, we are looking for, you know, specific conservation sites, drone operators that would be interested in, you know, funding and people that just can think about what we're collecting data-wise and use that for research. But my contact details are down bottom left, so please do reach out to me. But yeah, thank you very much, everyone, for listening.
Thank you very much, Barney. It's super exciting. Yeah, thanks for sharing the really awesome initiative that you developed. Please put your contact details in the chat as well, in case a few people want to reach out to you. We've had a couple of questions coming at the end. We've got a few minutes. So first of all, from Riley, are you using videos or images? If images, how do you account for double counting?
So we are using we're splitting our videos that we've created into images, and we're using the images to train the AI model. But when we are going to be in the field, we will be the inference will be on video feed, and using technical partners such as VisGuard that we have had conversations with. Their software allows for tracking of objects through the screen. So therefore, as the drone flies over, the tracking will continuously happen until the animal's from the top, since the drone's passed over it, rather than it doing double counting and sending that through.
Fantastic. And what is the drone that you're using? That was a question from Martin.
Well, so we're going to use a fixed wing drone. We haven't got a specific type yet. What we are not labeling ourselves is as a drone operator or manufacturer. So we want to work through licensed drone partners. We have a drone partner in Nairobi called Phantom Technologies, and we're currently in discussions with multiple drone companies to discuss maybe which drone platform we're going to use, and that would work with our kind of setup. So I don't have a specific type for you currently, unfortunately.
Thank you very much. And there's a couple more questions in the chat, which I would love for you to go and answer. Maybe Dan could jump in as well. But yeah, some really great questions from Bhavesh and Maria. But thank you so much, Barney. I think we're on time now to move on to our final short talk. So, William, I'm going to hand the screen over to you. Please go ahead.
Great. Well, thank you for inviting me to talk. My name is William Rees. I'm a PhD researcher at the University of Exeter. I'm also a bat worker in the United Kingdom and an enthusiastic tech user. So I'm going to talk to you today about a project I've been working on called Scaling Bat Roost Surveys, AI-assisted video review. So to begin with, why monitor bats? So globally, bats represent 20% of all described mammal species. Many species are synanthropic in that they live and breed in close proximity to humans, often in man-made structures. So they're at high risk of human-wildlife conflict. They also provide a lot of vital ecosystem services like pest suppression, pollination, and serve as indicators of ecosystem health. So monitoring is extremely important. And video-based monitoring is one of the most effective tools we have available to achieve this. In fact, in the United Kingdom, if you're doing presence-absence surveys that are going to be used for development purposes or conservation purposes, night vision aids such as infrared cameras or thermal cameras are actually mandated. The problem is that this produces a lot of data. So if you're doing a traditional dusk emergence survey, you will record for about 2.5 hours post-dust. And if you've got multiple cameras, that's a lot of footage to go through, and humans are really bad at reviewing long-form videos. So this project was really about addressing this problem. So exploring specifically, number one, are deep learning image classifiers currently able to distinguish between bats and non-bats in relatively low contrast, low resolution footage, like you can see below? The second was, can we combine motion tracking with an AI-based filter to essentially scrub through long-form videos and highlight events of interest that we can put in front of our practitioners? And the third, and most important tool from my perspective, is to compact all this into an open access tool for conservationists. So to explore this, we worked with a data set collected by professional ecologists in the United Kingdom, covering 20 sites and 61 independent scenes. We've got a wide range of species in our data sets, small and large, slow and fast flying species. So there's a list there if you want to review them in more detail. Overall, we had 150 hours of video footage, so quite a lot. And the first thing we did was split it on an 80-20 splits on a location basis. And this basically ensures that everything we're testing on and I'm reporting in terms of performance metrics was not used to train the model. The pipeline involves essentially first detecting motion within videos, tracking motion within videos, and then extracting essentially image sequences from that motion. These tracked objects are presented in essentially a simple web interface grid format, allowing a user or a researcher to essentially go through and very quickly annotate it into different classes. So it's just classifying your motion manually, basically, really efficiently. For our purposes, we chose 4 classes: bat, bird, human, and other. And we converted that 150 hours of video into essentially 85,000 frames of bats, 25,000 frames of birds, 60,000 frames of humans, and a big class of other, which basically represents everything else in our video. We then fed this through a deep learning image classifier. It's a ResNet 18 convolutional neural network. And this basically converts crops from our videos, so 64 by 64 inputs, into basically a vector representation. So it extracts image features and uses that to distinguish the classes. So in our case, bat, bird, human, or other. We then aggregate basically these frame level predictions across an image sequence to get an overall prediction that an object, so the thing you see in the top left-hand corner, is a bat or not. And overall, we were really happy with the performance we're achieving on even a really, really lightweight and small classifier. So this is only looking at 64 by 64 pixels. So it's a really lightweight process. It can run on any basically local hardware. We evaluate performance using first leave one site out cross-validation. So basically training on all our sites apart from one and then testing on that independent site. So it represents essentially what a practitioner would do, try and deploy it in a new location. And we found it was really effective at distinguishing between our classes. And specifically, you can see here 91% of the bat frames were actually returned as bat, which is perfect. But what's also really important is even though our model is 4 classes, we actually found that the bat head or the bat class itself was a really good predictor or detector of bats. So you can see in the top right hand corner, basically all our bat images are in red and they're pushed up to 1, so a confidence of 1, and everything else in blue, all our other objects are pushed down to near 0. So again, really good, very clear decision threshold. We then basically took this pipeline and ran it on our held out data. So the 41.5 hours of video we initially set aside that we didn't look at all. And what we found was that it was a really effective solution to basically screen and scrub through this data. We found that we returned 97% of all the bat events in the videos, at the same time reducing the amount of motion events we actually needed to review by 86%, and overall achieving a reduction of 98% in the total amount of video footage that a practitioner actually has to look at. So the next and most important step is creating something that people can actually use. And this is currently a work in progress, but we do have a public beta available. The tool is called WingSeat. You can see here basically what we call the review interface. And this presents all motion in the video basically in a very simple and accessible interface. But you can see here, motion is not very informative. That's a lot of information still to go through if you still rely on motion. But when you apply our filter, suddenly the bats appear. So really where we're at the moment is trying to hone the actual usable interface for practitioners. The demo is available by a QR code in the bottom left-hand corner if you want to see a full video of the end-to-end process of analyzing your data. There's a link there to submit clips to our central database, because the more data we have, the better the tool will perform. At the same time, we've got UK species only. It'll be great to see some collaboration on an international scale. My contact details there. I'd love to hear more about what you're doing with bats and whether you'd like to use this tool for any of your research or conservation work. Thank you.
Thank you very much, William. Really appreciate that. It's when you show the image with all the different lines on it, sort of crossing over it, it shows how difficult it is to analyze. But then when you take that off and you see the bats flying around, it suddenly all makes sense. Thank you so much for sharing. Do we have any questions from the chat? from the audience for Will? If not, I do have a question. I was going to ask because, as you said at the end there, the tool is kind of very specific for UK bats at the moment, and we've only got a limited number of bat species. How accessible is the tool going to be for people from other countries or other regions to use? Maybe when they're working with larger bats, diurnal bats like fruit bats, that sort of thing. Is it going to be an accessible tool for them as well?
Yeah, so if we're talking about fruit bats, the visual similarity to some of the large birds we've got in the UK will probably cause a bit of an issue there. But insectivorous bats, generally, it's trained basically on very low resolution image inputs, specifically the silhouettes of bats and their wings. So if you've got the characteristic, I don't know, Batman silhouette, you'll probably be okay. But ultimately, what we need is data from the international community to really validate this. And part of the platform we're providing is also a showcase on how you can evaluate the tool on your own data as well, which is absolutely critical if you're ever using an AI tool. Figure out if it works on your own data.
Amazing, thank you. We're getting some bat love from Kalindi in the chat, and also David has asked, is there a link to the online platform or is it still a work in progress?
I'll post the Git repo in the chat. Yeah.
Fantastic. Well, thank you very much. So that concludes our short talk. The really, really interesting of different AI applications across like a full spectrum of conservation project. So I'm just going to share my screen now because we're jumping into our ad break. Okay, so now it's time for our regular ad break where we share community updates and any updates from the WildLabs team as well that we want to share with you guys. If anyone on the call wants to announce something that we don't cover, please raise your hand and you've got some time to speak. So yeah, just raise your hands and we'll type something in the chat and we'll give you a platform to announce something. But primarily, we wanted to take this time to highlight some community events and webinars that are happening in June. And we'll post some relevant links in the chat in case you're interested, so you can go and check them out. Firstly, there are 2 vibe coding sessions being held on June the 10th and 11th. So come along to those if you're interested in using AI-assisted tools to build apps, games, or code with natural language prompts. There's a link to register on the screen there if you just want to scan that QR code, but I'll post the links in a minute as well. On the 25th of June, there'll be a webinar on nature credit markers run by Sensing Clues, and the session will explore how transparent conservation data can improve reporting and support community-led conservation. So please check that out if you're interested. And coming up next week on the 2nd of June, there'll be a session on Bugs to Bytes, which is a free platform for managing ecological research data. Please head along to this session if you want to learn more about that tool. And if any of those event organisers are in the call at the moment, please do type more information in the chat or put your hand up and we'll give you a platform to speak more about them. And the last thing I wanted to mention is the Computer Vision and Pattern Recognition Conference, which is happening in Denver, Colorado soon. So if you're heading there, please reach out to Riley, who I believe is on this call. So Riley, I don't know if you're here and you want to speak about this, but I believe they're organising an AI for Conservation bird walk on the morning of June the 5th. So Riley, if you're on the call, please mention that in the chat.
I'll link the flyer.
Excellent. Well, thank you very much for sharing that. Otherwise, now we can move on to our famous quiz. And normally we try to do it on a theme, that's based around the talk. So I was thinking, okay, well, maybe I should try and put together an AI-based quiz. Maybe I could use ChatGPT or an LLM to help me design it. But then I thought, based on popular demand, we wanted to return one of our better quizzes from the past because I couldn't think of a particularly interesting AI-based quiz. So we're going to return to an old classic, which is moth, mushroom, or metal band. Completely unrelated to the talk, it's very good. So to quickly explain what this is, there is a phenomenon where the names of moths, mushrooms, and metal bands all sound very similar. So we're going to test ourselves by looking at some words and then writing in the chat if we think they're a moth, mushroom, or metal band before revealing the answer. So I'm going to open up the chat and then we can get started. But yeah, please write in the chat. I hope that all makes sense. And I think we can proceed. So first of all, Velvet Shank, do we think this is a moth? Do we think it's a mushroom? Or do we think it's a metal band? Please type in the chat. Adrian says moth, mushroom. This is the dilemma. It could be any of them. Metal band. Okay, Andres says band. Well, I'll put you out of your misery. Bellwitch Hang is, in fact, a type of mushroom. Very exciting looking mushroom as well. So everyone that said mushroom gives themselves a point. Second one is the toadflax brocade. This one's easy, surely. Moth mushroom or metal band? Moth, mushroom, mushroom, moth, 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 moth. No one thinks there's a metal band called the toadflax brocade. I'm not surprised. Okay, I can confirm the toadflax brocade is in fact a moth, and like a very interesting, fuzzy looking one. It said moth, please give yourselves a point. Nightwish, moth, mushroom, or metal band? This one's got to be easy. Metal band, metal band, metal band. I feel like a few people actually do just kind of know. Yes, no, in fact, a metal band. Great outfits. Dark Archers, moth, mushroom, or metal band? Moth, 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 metal band. Martin says metal band. It would be a good name. Mushroom band. The answer is moth. And it does look quite similar to the other one. Sorry if that offends any moth experts in the room. Devil's Tooth, moth, mushroom, or metal band? Mushroom, 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 mushroom. Okay, people seem to be very confident about this one. Maybe this is quite famous. Yes, because this is in fact weirdest looking mushroom I've ever seen in my entire life. So maybe it's more popular than I realized. Okay, this is the last one, I think. Three nuts disco, moth, mushroom, or metal band? Moth, of course. Band, moth, metal band, band. A lot of people think this is a band. I can confirm for our final one, it is a mushroom, and I don't know how they came up with that name, but yeah, there it is, the Hairy Nuts Disco, a particularly charismatic looking fungi right there. So if everyone got those right, please type down in the chat what score you got, and I hope you enjoyed this round of Moth Mushroom Metal Band. But with that, I think we can move into our final long talk today. So Martin, I'm going to hand over to you, and you have until the end of the call. So please do take us away.
Oh, wow. Thank you, Henry. Well, I'm not prepared for a 30-minute talk, but this was awesome. This was so much fun. Great to meet you all. My name is Martin Sommerschuh. I'm Senior Manager for Partnerships with Impact at Global Nature Watch at the World Resources Institute. I'm helping ensure our open access geospatial data and tools are responsive to the needs of a wide range of users and help make impact on the ground. So thanks for having me today. I'm presenting on behalf of Jessica Webb, our lead for Forests and Nature for People, who couldn't be here today. So I will present a demo of Global Nature Watch, which is an evolution of Global Forest Watch, which some or many of you may know. Global Forest Watch was a step change in how we're able to monitor forests around the globe with open, globally consistent, regularly updated data. Global Forest Watch, with Global Forest Watch and of course other tools, we were able to show that monitoring works. We've been able to prove it with independent studies. For example, researchers in the Peruvian have compared deforestation across communities in the Peruvian Amazon and found that in communities that use tools like Global Forest Watch, deforestation was lower than in communities that don't, to a statistically significant extent. And then through our work in Land and Carbon Lab, we've expanded land monitoring beyond forests to all land and the associated carbon flows over the last couple of years. So this all adds complexity. Already, Global Forest Watch has dozens of data sets. And with this new data coming from Land and Carbon Lab, we were facing the challenge of how to make this accessible and digestible to audiences that are not specialists, may have little to no geospatial knowledge, and don't speak English. And that's where Global Nature Watch comes in. So Global Nature Watch is a chat-based map interface that lets you ask plain language questions about land and forest-related data. Users can ask questions in more than 100 languages, get answers with maps, statistics, and context, and the system integrates near real-time and annual satellite data and reveals change across ecosystems from forests to grasslands, croplands, and other natural lands. How does it work? You ask a question, and then a system of AI agents analyzes the intent and accesses an API to retrieve the data needed. An API which from the last couple of talks, I imagine most of you know what that is. It's an application programming interface. So essentially a way for websites to exchange information. The data that's in the system is for now only data that's from WI, all open access and peer-reviewed. The agents then return a response based on the analysis accessed through the API. So what's important here is that the analysis is not done by an AI. It is that the analysis is done through the API that provides a deterministic result with no kind of AI components. What the AI does do is present the results and put it into context. So it will build charts, provide insights into what the numbers mean, what they don't mean, and then return results in the language that the user requested. Before I show you a few demos of how this works, a quick overview over the data sets. So for now, we're only adding WI data to Global Nature Watch, starting with the forest and land cover related data sets from Global Forest Watch and Land and Carbon Lab. We realize that that's a significant limitation for now. However, this has to do with ensuring the scientific integrity of the outputs, where our researchers vet the ways the data can be intersected and analyzed so that the outputs are defensible. It's definitely in consideration for a future kind of product roadmap to give users the ability to bring their own data sets. It's already possible for users to upload their own polygons and then run analyses on them. And as many of you may be aware, kind of a short tangent here with geospatial data sets, as many of you will know, there are trade-offs between kind of global consistency or comparability and local accuracy. So whenever you use the data, it should always only be a starting point, and local verification is required using, for example, all the tools the previous speakers presented. So without further ado, let's see how this works. The first prompt, identify areas in Peru that are at high risk of near-term deforestation based on recent trends. Recent trends is a hint to use our near real-term alerts rather than annual data. And you'll see here the interface is a map with relatively few controls and a chat pane. And I've just pre-recorded this to reduce the risk of technical failure. But you can all check it out yourself on globalnaturewatch.org. So the system thinks will by itself pick the right data set, and then we'll run an analysis across the departments of Peru. And we'll find the ones with the highest number of disturbance alerts. And in this case, it found out that in Loreto, in the Amazon, was where the highest number of alerts were. It summarizes the findings and gives down here a few caveats on what the alerts are doing and what they're not doing. And then maybe we'll ask it a follow-up questions. For example, my organization wants to invest in protecting biodiversity. Based on this data, which one of the major national parks in Loreto should be prioritized and why? And it will go ahead and find those major national parks, run the analysis, and calculate a result. And let's see what it comes up with. It says that the Sierra del Divisor National Park is recommended, gives a bunch of reasons for that, and provides context when making that recommendation. Again, the analysis here is done through the API, so it's not AI. What's AI is the presentation of the results and the interpretation of and their interpretation. Let's go to another demo, if I can find the right slide. Okay, there we go. What are the long-term deforestation trends in Madre de Dios, and what are the major drivers of loss? So this uses WI data that's more annual. Again, it picks the area and the data set, produces the result. You may know, some of you may be aware of the annual tree cover loss release that WI has been doing for over a decade now. So we actually have a complementary data set to this, which is called Tree Cover Loss by Dominant Driver, which points to the key reason behind a loss event of forests. We're working to the same resolution that the tree cover loss release has. Now you see a chart that's produced here. The key reason of loss was permanent agriculture, and followed by hard commodities over the last 20 or so years. It provides context. For example, it explains what shifting conservation means. It explains what, in this context, commodity-driven deforestation, that is that is more likely in this area to be associated with gold mining and agricultural expansion, and a few other kind of data caveats. And let's ask a follow-up question. How could acoustic monitoring or environmental DNA data be integrated with forest loss data to improve biodiversity risk assessment? And the response it returns talks a little bit about kind of where the limitations of satellite data are and how these might be overcome with field measurements. Again, the really interesting talks that we already heard earlier in this hour. And then if we have a little bit of time, I will do a third one. This is going to be quick, related to transparency in the age of AI. So this is around grasslands-related data that our researchers at Atlantic Carbon Lab have produced to close a big gap in global data, as grasslands make up a quite significant amount of global land. So let's see what happens. Again, it looks at data, it looks at the data we have, produces a chart, and then there's this little button there that says, view how this was generated. And you can click on it, and what happens when you do is it surfaces the code that the AI generated for the creation of the chart and the process behind this. And I recognize, this feature may not be of interest to less technical people, but it helps particularly with more technically advanced users to show the process of how the AI got to a result, to really allow it to look under the hood of what was happening. There is a help center that provides guidance on how best to use Global Nature Watch. It describes the capabilities more in detail and has more of the technical specifications. For now, we have a limit of 10 prompts per user per day. We've instituted that so that we can gather data on usage and cost and kind of keep tabs on the environmental implications of this technology. You already can, as I mentioned before, I think you already can upload your own shapefiles for analysis. And then the system has preloaded a few levels of administrative areas, of protected areas, key biodiversity areas, some community and indigenous areas for analysis. Current supported workflows are on this slide. These are not things that a geospatial specialist cannot do with GIS software. It's more our hope that this will reduce the barrier to the use of geospatial data for people who are not specialists, and will make analysis quicker for those who are. And what's really key here is that this is not a finished platform. We're in a period of learning and collaboration, and kind of need your feedback. So we're still adding capabilities. For example, right now our product team is noodling over how to make the monitoring of groups of areas of interest easier, say when you want to monitor 10 protected areas at the same time. So really invite you to access the platform at globalnaturewatch.org and try it out. It will still break every now and then, so apologies in advance for that, but that's what we need, kind of why we need this community feedback. For more structured feedback, you can complete a survey and join a user research panel for targeted interviews that help shape the direction of Global Nature Watch. This is something I would really like to emphasize again. We're not done building this. We're still continuously making decisions on where to go next. And really, our users truly help shape this future direction. We have ongoing user interviews that our user research team is running, and you're welcome to sign up for this panel with this QR code. And then, I think before we jump into comments and questions, wanted to share a few initial ways on how this could be useful for the community now that you've seen a few demos. Again, sign up and if as you try it out, and as you were thinking, as you're working through prompts that might be of interest, think about how this could help your work in the future if some of the kinks are worked out, and if say there's further availability of data sets and additional functionalities as kind of a future state of where we could go. A few angles come to mind. I'm fairly new to this community, and thank you again for having me. So the initial kind of ways that I've thought about are Global Nature Watch already has the drivers of tree cover loss data that points to a likely key reason of a tree cover loss event. Our teams are now also working on the drivers of alerts. So applying the same content from no longer only to annual monitoring, but also to near real-time monitoring, where a loss event shows up a few days after it actually happens when it's picked up by satellites. So stay tuned for that. Somewhat related, Global Nature Watch may provide quicker access to get to those alerts and early warnings for protected area managers. So think, rangers, a chat interface that lets you create your areas of interest quickly for updates since you last checked. So ultimately, the goal is less need for specialists to get involved, or their ability to drill deeper, and more time for folks in the field doing what we all love to do. And to really get there, we're looking for your comments, inputs, and on what would be helpful. And lastly, I'll preview a little bit that we are exploring multimodal approaches that bring together different types of data. So we're starting to work on a project called Amazonia, a new initiative that combines monitoring technologies and data across the Amazon, specifically camera traps, acoustic sensors, and eDNA with satellite data to create ecosystem condition alerts, biodiversity change trends, and ecosystem integrity indicators. And together, we hope this will paint a fuller picture of the state of biodiversity across kind of larger sites and inform decision making. So my mental model here is picking up data that was collected in situ, and then with the help of satellite data, figuring out what's happening in between those sites. This is a very new project, will take a few years, and it's a big consortium effort where WI is just one small piece of a big puzzle, but may be of interest to some folks here. And with that, thank you for your attention, and thank you for having me, and looking forward to the conversation.
Thank you so much, Martin. Appreciate it. It's such an amazing tool, and I can just see it's just going to be so practically useful for conservationists just all over the world. So thank you for sharing, and thank you for developing it as well, of course. Do you have any questions from the audience for Martin? I didn't see anything come up in the chat, but we've got some minutes now if anyone wanted to unmute themselves and ask in real time. William, I see you just posted something in the chat. I wonder if you wanted to just ask directly.
Yeah, I was just wondering what specifically documentation you're using for your RAG system for the chat interface, I guess, and about the transparency of that information and the openness, really.
Yes, they are open. I'm not like so much in the technical weeds. I don't know the exact name of that, but I'll find out. I know we're using Google Gemini Pro as the kind of the public facing system that creates the charts. We do have code on GitHub and all that fun stuff. I'll find you the site where that's I'll throw in the link where that's all listed.
Great, thank you.
Thank you very much. Martin's highlighted some important potential users: Mossy Earth, Planet Wild, and IUCN. So maybe Martin, that's helpful for you. I did have a question as well. You might have mentioned it, but I just want to check: is it available in multiple languages at the moment? So can the information that comes out of it, and what languages is it available in?
It is available in all the languages that Google Gemini Pro supports.
Fantastic.
So I am German myself, and what really blew my mind was asking. So it starts in English, but the moment you throw in, say, a question in German or in a different, it picks up on that and will respond. That will immediately return in your question. Will return the response in your language. And what really blew my mind there was like, oh, I can finally explain what I do to my parents. Because I don't have to come up with some clunky translations of complex English terms into German where I'm not really the expert.
It's remarkable what we can do now, and the fact that it can even pick up on those sort of like cultural contexts and translate them over as well, I think is just incredible. So yeah, really great to
Well,
get
yeah.
multiple languages.
And what we still need to do there is a little bit, and what we've started doing is fine-tuning it per each language, because some terms are fairly politically contested. So, you know, the differentiation between tree cover loss and deforestation. Tree cover loss doesn't always equal deforestation. That's nuance that we will still work on in the major languages. But for example, it will help. Hopefully, it will help kind of decision makers who have to produce and for, say, you know, government officials who just have to produce by default reports in their official languages.
Fantastic. And you mentioned one of the things that you mentioned at the moment, you're allowing 10 prompts per user at the moment in sort of this more kind of pilot phase, not really a pilot testing phase. So you said there might be plans to increase the number of prompts that individual users can ask it, and will there ever be some kind of like maybe monetized version of it or feature that, you know, companies can access and use? Yeah, what are your plans in that regard?
So yes, and thank you for mentioning it. It is 10 prompts per user per day. So meaning every 24 hours it resets. So when you're done, when you've run out of your prompts, it's not like this is it forever and you just have to wait till the next day. That is a really important distinction. The idea is this is going to be a global public good, as everything we put out as WI, open access, free to use, including for commercial use. To kind of recover our costs for kind of super users, there will be a limit on how many prompts you can use per day. So we might increase it, but it's not going to go up. If you say, you know, you work for a company and you want to do supply chain due diligence, and then you have 500,000 polygons, that's something that would eat up our whole grant funding in an afternoon. And similarly to how we've done this with Global Forest Watch, yes, we would then kind of approach and see how we can recover our costs. But for your normal user, it will be free, and those limits are really, really quite high, because there's quite a gap between your normal user and what, you know, company and commercial applications need.
Thank you so much. Yeah, really appreciate the information. I think like the sustainability of like AI agents and LLMs and stuff is becoming a really interesting topic for our sector. So yeah, really excited to see how it develops, and yeah, really interested to see what comes out of the testing as well. So thank you very much for sharing.
Thanks for having me.
Pleasure. So I think that's it. So we've had all of our talks for today. We've still got a couple of minutes left. So I want to open up the floor for any kind of comments, reactions, any other questions that people didn't get to. Please go ahead. Any applications of AI that you've heard tonight that has surprised you the most?
I do have like a general question or thing I've been thinking about that is kind of related to what Martin was talking about, which is as we take away people's ability to interact with the data themselves, like because often, you know, like people watching videos, they would know what's happening in the videos. We take away some of the agency, but then because we have data centralized, we can then give new ways of access to that data. Like the example is here, or maybe dashboards and so on. So maybe if people have this, can you come out with and like what kind of dashboards or ways to interact with the data for people?
Yeah, I think one thing I don't know if I fully understood your question, but one thing that's really important for us is kind of the traceability of how the thought process went. So we've started instituting in the outputs, we started instituting ensuring that we know what's AI generated and and what's not. So you can see that in the text, and also kind of citing back to the data. again, the human, you can't take out the kind of the human aspect of the judgment that needs to go into ensuring that something is credible, scientifically valid, and so on. So I think we're aware that one limitation of this system is, or that kind of more technical audiences and specialists will still want to interact with the data, and that's good. It should be that way, and we don't want to take that away. So that you will still be guided to where the documentation is, and you can download the data where possible and then work with it yourself. Does that make sense?
Yeah, thanks. And actually, my question was a bit convoluted because it's just like a cloud of thought that I've been having. So you have answered like the point that you made of distinguishing what's AI and what's actually data is really good for me.
Fantastic. Thank you. Any more questions? Any more comments?
I mean, just to follow up on that point, I think human in the loop workflows are really like super important when it comes to the practical use of AI. Even if you're using BirdNet, like you shouldn't just trust the outputs that come out of it. You should go through and check your data yourself. You have to think about what's missed. So I think if talking about the BAT tool itself, one of the problems we've got in the UK is like if you're doing a nocturnal emergence survey, you might see bats, but ultimately there's some other things you sometimes find that are also pretty interesting. So barn owls are a protected species. If you're manually reviewing the videos and you're only looking for bats, you'll miss the other protected species. So you've always got to think of the trade-offs of a certain tool and what you're missing by relying on some sort of pre-processing. But all we can do is try and put humans in the loop wherever possible, in my view.
Thank you so much, Will, for that final reflection. And that brings us to time pretty much. So thank you so much, everyone, for joining. That's been our May Variety Hour. We've had some fantastic talks. Thanks, Martin. Thanks, Moshe. Thanks, Barney. And thanks, Will. Really great to hear about your work. And please follow up with them if you want to connect or learn anything else.